Next up, we have Bobbie LInd from Intel. She's a systems engineer in the High Performance Data Division. In this role, she helps various Intel partners, government customers, to create, maintain their Lustre file systems. She began her career in the United States Marines as a system administrator, continues this role in civilian life. She's worked for some U.S. government programs where she built, maintained several mission-critical Lustre file systems. She's been working with Lustre for 3 years, focusing on making it easier to understand, right on, as well as easier to support. She holds a bachelor's degree in computer science from Park University.
Thank you. Yes, you heard that right, a Marine with a degree. So today I'm talking about Lustre Tuning Parameters. The problem with, well, one of the many problems with learning Lustre for the first time when you're outside of the Lustre community is that the information isn't exactly easy to get to at times. So what I've kind of found about tuning Lustre in general is there's quite a mystery surrounding it. Everybody seems to have their own secret sauce when it comes to tuning Lustre, and unless you ask very specific questions, looking for very specific answer, while people are very willing to give this information, they still tend to hold a lot of it back because they're looking to try and answer your question, and you may not always know how to ask it. So some of the things that kind of go into this whole mystery of Lustre is what type of parameters are actually tunable. What are some of the more common parameters that you use for tuning? And how do I monitor these parameters? And that's very different from let's just benchmark the thing, tweak a couple of things, and then benchmark again. Sometimes it's nice to make educated guesses on what you're doing rather than, well, let's just change everything and see what that does. So the other big problem is, where do you find this information? The Lustre Operations Manual, we've already talked about that in a couple of presentations, is not always helpful. It'll get you about 80% of the way there, and then it teases you for the last 20%. Online, just about everything that you want to know about Lustre and tuning Lustre can actually be found online. The problem is finding it online. It seems to be everywhere. Sometimes it's difficult to find, and sometimes it's even difficult just to figure out that what you found is the answer that you're looking for. You can phone a friend, and I actually had the pleasure of learning from somebody who actually knew Lustre before I started working with it, and was very, very useful when I had questions. I would just call them up and go, I'm completely lost, what am I doing? The other thing is, what we're working on in the HPDD division with our systems engineers is we're working on actually creating a tuning class so that some of this type of information is actually going to be available in one easy-to-find location. What adds to the mystery of Lustre itself is the many different layers that actually require tuning so that you can successfully get Lustre to perform better. There are 6 different possible ways to tune Lustre, 6 different layers that you can work on. Everything from the underlying OS, the physical network layer, the back-end storage, LNet itself, application I/O, and then the actual Lustre software. Being that this is only a 20-minute talk, that I'm just going to talk about the Lustre software specifically in this one. So finding your tuning sweet spot. How do you do this as an administrator? The couple of different things to take a look at is, you first of all got to figure out what type of data you're intending to run on Lustre. Are they large files? Are they small files? Are they video files? Sometimes what type of video file can make a big difference. Is it something else that, what is your type of data? What specifically are you tuning for? Then you need to actually benchmark your system, because you need to know where you're starting so you get your baseline platform. The next most critical part, which is actually incredibly difficult to do sometimes, is truly to monitor those parameters that you're getting ready to change. How do you take a look and say, what does this parameter specifically do if I change it, and how do I know that if I'm changing something that it's actually going to be effective for what I'm looking for? Once you've found the parameters that you're looking to change and you change them, then you go through and you re-benchmark your system, and that's, one of the more effective ways of knowing how it is that you've done things. So what I've been told before in the past is, the best way to know when your system is tuned is you just rerun your application, which is fine until you've got applications that take 12 hours to complete. I don't want to have to try and run an application for 12 hours just to know that my system has been tuned. So I took a look and trying to figure out, what actually can you tune inside of the Lustre software, and does it even provide a measure of increase in your performance? So I took the 2.15 release, which is the most current maintenance release that we've got, and I set it up on, granted, a very small Lustre setup, one MDS, 4 OSSs with 1 OST per OSS, 2 clients, and this was on Ethernet because I can't afford InfiniBand in my house yet. So I took a 300 megabyte file, and that was going to be my sample file size for this benchmark. I used IOZone, DD, and MDTest to get the baseline for what I had started. So this is out of the box 2.15 install. I know there's a lot of information on this slide, and it may not be so easy. It's not so easy to see, especially in the back. But this is the basic data that comes from being out from IOZone, DD, and MDTest. So what I took from here then is said, what are the most common Lustre-specific tuning parameters that I can find on the internet and talking with everybody? And it kind of comes down to stripe size, your max RPCs in flight, read cache, the max 30 megabytes, and max read ahead. And I took a look at these and said, okay, let's take these. How do I monitor them? How do I know that if I'm going to change this, I can watch it and see what it's doing as I'm either looking at it with my data or what happens when I change it? So RPCs, there's actually a really, really cool file that's in there and under the OSC import, which is real-time RPC data. So when you run that file, it shows you, it's a live snapshot on exactly what's going on with your RPC. So it'll tell you how many RPCs in flight you're currently using at that point in time. And you can use RPC stats to get the collection of it. So it'll break it down and show you whether you've got 40% of your system, 40% of your RPCs are at 1 RPC per flight and 40% are stuck at 8. For stripe size, about the best way that I found for monitoring stripe size and how it affects something is to really just run a straight up DD. It's not always the prettiest and most effective way for parallel files, but it certainly gives you a good understanding of what the difference between 1 stripe and 4 stripes and however many OSTs you have. As far as monitoring the I/O patterns, this one was actually really difficult for me to try and figure out how to do. BRW stats will give you an idea on what size of I/Os you're running, but it encapsulates them all together. So it'll tell you you've got 90% of your I/Os coming across as 1 meg, but that doesn't actually tell me what my I/O pattern is. So after a little bit more searching around on the internet, I found strace. And I've used strace a lot of times in debugging, but didn't realize that you could actually use it for determining the I/O pattern of your application. And it kind of gives you an awful lot of really good information as far as just simply, are you running large I/O, then small I/O, then large I/O, and then small I/O again. It's certainly one of the things for in the future is the Intel Manager for Lustre. It's one of the things that we're working on as far as we're going to, they're looking at giving the ability to monitor a lot of these different parameters that are being set so that they can so that it helps the end user, the administrator, actually look at what's going on in the system at any one point in time that should help this. So after going through and taking a look at all of those, I went through and re-benchmarked my system. This is the output and the results of that, but again, this isn't necessarily the most useful data for you guys here. So IOZone. I know the graphs look a little skewed, but don't let that fool you. IOZone changed by about 2% by just changing one layer of the file system, going from 8 RPCs in flight to 12 RPCs in flight. You know, changing my max dirty megabits to 128 megabits. I managed to increase both reads and writes about 2% between the first run and the second run. Again, with DD, the graph looks a little bit different, but if you take a look at at the scale of it, again, it's about 2% where the reads and writes were changed. It went a 10.7 megabits per second to 11 megabits per second for a write isn't a significant change, but I was only changing one of the 6 layers. And again, you take a look at the MDTest. This one here is a little bit more accurate for kind of how you think. The difference between your light blue and your dark blue isn't quite a significant jump in this graph, but again, just about everything here ended up to being about a 2% increase just by changing one layer. Now, so that's pretty much the end of my talk at this point, but what we really get is if I can get a 2% increase on just changing one layer, there are 6 different layers that we can change, and this is just dealing with simple tuning parameters. So there's an awful lot that you have the availability for to do in just simply tuning Lustre and trying to optimize it for what you're looking for. So, thank you.
Thanks. Questions?
Got one. Hang on, I think they're walking the mic back.
There's a lot of layers there to tune. Do you think that the complexity is really worth it, or do you think Lustre should really invest into a auto-tuning layer like GPFS has, where I can say on a client I want 100 megabytes per second, tune that parameter and have Lustre give the feedback and auto-tune it for me?
There's a lot to be said for kind of, I would call them canned tunes, really. Can we sit there and say, if you're going to start, with Lustre out of the box, can we take it and say, you're kind of doing about 300 megabytes for your file size. Here's a start to what we should have for tuning. I absolutely think that we can do that, and I don't know how or what the best way would be doing that, but I certainly think that kind of a general starting point would absolutely help for something like that, and I'm not sure. I'm not sure the best way to go about doing that, but an auto-tuning feature of some type, I think, would be very effective.
About your example,
Sure.
Could you tell us what was the framework where you were working? Because I think that this improvement in performance depends not just on the simple number, like you increase, for example, the RPC in flight. Mm-hmm. But I think they depends also on the amount of RAM that you have, for example, on the machine hosting the MDS and the machine hosting the OSS.
Absolutely. So you can almost say that there was another layer that you could really have as far as tuning, and that was the physical hardware itself. So yes, there is going to be a difference between running 1 meg of RAM and running 36 megs of RAM in your system. And you're absolutely right that would make a huge difference. At this point in time, all I was looking at doing was taking what I had and just tuning the one specific layer of Lustre, of the software itself. But absolutely, if you change something in the physical hardware, then yes, that would make a huge difference on even just the simple results that I got. Did that answer your question?
Okay.
All right. Anyone else? No? Bobbie LInd, thank you.
Thank you.